We're going to talk about OptiInstrument software, which we introduced like a few months ago during the first showcase. And today we're going to talk about a new feature has been added into the software, which is logic control feature. And before I start on the talking about the new addition onto the software, I'm going to give also a small history about OptiWave. So OptiWave has been established in 1994. It's located in Ottawa, Ontario, Canada. We specialized in software tools to design, simulate, and optimize components and systems, as well as links and networks. OptiWave software is distinct in a way that it can provide advantages to many issues, which is related to the shortening the production time, improving the product quality, and as well as enhancing the productivity and cost effectiveness through the simulation process. The product line of OptiWave has been licensed into over 1,000 industry-leading companies, universities, research institutions, as well as governmental institutions in over than 80 countries. Our main product can be categorized into a system-level product, which we have two software called OptiSystem and OptiSpice, which is an optoelectronic software. And we have component levels. We have different packages here, as you can see: OptiPBM, OptiFDDT, OptiFiber, and OptiGrating. And today's we're going to concentrate on OptiInstrument software. If you would like to have any of these types of software, you can go to OptiWave website and you can go to the download page here, and you can download a 30 days evaluation like for the software. But first, you need to register into the forum, and then after you register, you can download the software for 30 days. Now, once you download the software is going to be downloaded into onto a C drive on program files, Opti software, and then there you're going to see different libraries, directories. Here you can see the bin directory and documentation, which would have the executable file, which you can run it from here, or you can run it from the Explorer. And as well as you have all the documentation information about the software. Now, this is the graphical user interface for OptiInstrument version 1, which is, we did the modification on it. We had to add up the logic control feature on it. And so this is what will happen is, if you, the details about every key here in the software, you can find it on our website, and you can see how is the different keys are working and functions. Today, we're going to concentrate mainly on the version 2, which has the logic control. So as you can see here, we added up a new tab, which is called logic controls. And once you click on it, you have all these logic commands and helpers, basic helpers, as you see. And then also we added up into the command sequence output tab here, where the results of the sequence, when you execute, it's going to be stored in the output file. And then in the output file, you can download it as a CSV file or a JSON file. Now, OptiInstrument in general, just to give some features of it here, like you can operate the software remotely or locally. So you can do if you have USB keys or GPIP or whatever the physical connection, you can do it, or you can do it remotely through the internet. You can execute one single command or a sequence of skippy commands to control the instrument. And you can load your own XML files to the GUI, as well as you can upload any type of file into the platform where you can access it. Like all types of files are allowed to also load. However, all the commands, as I mentioned, they are executed through the skippy commands. Now you can drag and drop the skippy commands in the sequence, and then you can arrange them up and down. And also you can generate a Python script for this sequence of commands, and you can run this Python script externally from the prompt command, or you can run it from a built-in Python editor window, which is in the GUI. Now, the saving of the files, as I mentioned, we can do it through CSV file or JSON file. And the GUI support dockable windows. You can drag them and place them anywhere in the GUI. Now, the new stuff which we add up, as I mentioned earlier, is the logic control, which we're gonna demonstrate today through a recording, and then you are welcome to join us in the breakout room to view a live demonstration and ask any question. The other thing which added up also in this version is the time delay. Typically with Skippy commands, because of the different equipments, some of equipments need longer time to execute the command. So we allow now independent command delay control. So you can set up your own delay for every command. Now, OptiInstrument Applications, as I mentioned, it can be remotely, locally communicate and control the instruments. You can set up parameters, you can measure, you can automate any test setup which you are willing to or you're planning to do. Now, in the process, you can also do long-term stability testing. So with the logic control added, you can have if statements, while loops, and so on to enable stability testing and long-term testing. You can have also display generated signals. So we have a viewer, which is we demonstrated in the version 1, and it's existing also in version 2 as well. You can save files, as we said, and we can extract the data. And also you can integrate the instrument into other software, so you can extract data and use it in simulation software. Now we're gonna show you the demo for OptiInstrument logic control, which is basically built based on an LTB8 test track from Expo. So we have 4 laser cards and a switch, then an attenuator and an OSA card. And we control the operation in this demo as my colleagues we're gonna show you here in the recording. So I'm going to start the recording.
Hello, my name is Alex. I'm one of the developers, and today I'll be demonstrating the changes for the OptiInstrument 2.0.
Hey, Ahmed, it looks like the audio cut out a bit.
I'm not sure what's happened, honestly. I tried to
release. A major overhaul was done to the sequence of commands to allow for looping and more sophisticated tests. Before, each line was calculated separately, which became a problem for longer scripts. Now repetition can be easily automated. While most of the software seems familiar, you'll notice a new tab has been added. This is the Logic Controls tab that we'll be constructing our sequence with the combination of control blocks and basic helpers. And one thing that I really want to emphasize is the simplicity and the effectiveness of the new changes. And to do so, I will work through an example that I've made. First, I'm going to load the example phase change, which connects to the wriggle function generator and changes the phase to our liking. I'll drag this into our sequence of commands, and here you can see I have an initial variable of 15, an incrementation of 15 inside a for loop that runs 7 times and changes the phase each time. So I will generate a Python script here, and I'll execute the script. Here we can see that the phase was changed 7 times from 15 to 105. Now, let's say I wanted to now run this 50 times. All I would have to do is change the number within the for loop. Create the script, execute it, and we should see 50 changes here from 15 all the way to 360. Now, one thing that I don't like is this repetition of 360. So what I can do is first I can make the syntax look prettier. What I want to do is I'm going to drag in a print statement, and I'm going to set this skip command here to a variable called phase. So if I do this, I can print it in here now. I can say the phase is like this. Phase. And what I'm going to do also is I'm going to create an if statement to stop the sequence once it reaches 360. So here I'm going to drag in an if statement and say when the phase is equal to 360, I want it to break from my loop. And I'm going to generate the Python script run the Python script, and we should see a prettier syntax and that the script actually terminated at 360. And this can all be controlled by the user to fit whatever needs they want. Any print statements, any conditions, any type of looping. Another thing that is really user-friendly is now all the commands. So I can move commands up and down. I can undo, redo. I can clear the sequence. I can drag in the sequence. I can delete it again, or I can update it, anything. And now I will be demonstrating a more complicated example. And in this example, there are, once again, skipping commands, there are individual sleep times, and most importantly, there is a doubly nested for loop within a while loop. And to demonstrate this, my partner JD will explain what the sequence does.
I'm JD, test engineer working on OptiInstrument. So today I'll be going over the demo sequence setup and how the sequence is laid out. So let me first go over the setup. So we have here 4 different instruments inserted into Expo LTBA platform. So first we have 4 continuous wave lasers, and then an optical switch, which is 1x16, then a variable optical attenuator, and an optical spectrum analyzer. So we have 4 lasers connected to the optical switch output using fibers. And then the input is connected to the optical attenuator, where we'll be changing the attenuation value. And then the attenuator is connected to the optical spectrum analyzer, where we'll be performing certain measurements. And so this is the setup we have. And then in terms of the sequence, when we start the sequence, first we switch the optical switch path to 1419 nanometer laser source. Then we turn on the laser source, and then we go to the attenuator where we set up the input wavelength and set the attenuation to minimum. Then we move on to the OIDA where we set up scanning wavelength boundaries, and then we initiate the scan and measure peak power. So once we have our peak power value, we enter our first logical loop, where first we encounter the conditional statement, and in this statement we check if the peak power is less than 0 dBm or greater than -10 dBm. If the condition is met, then we enter the loop. Otherwise, we exit the loop and turn off the laser. So once we enter the loop, we go and measure peak power 5 times. And once we have those values, we exit the loop and turn off the laser and move to the next laser source. We move to the next laser source by switching the optical switch path to 1550 nanometer laser source. Then we turn on the laser source. We set up the input wavelengths for the attenuator. And in this case, we won't be setting the attenuation because, as you will see in the later part of the sequence, we will be changing the attenuation value during the sequence. And so after that, we go to the OIDA where we set up scanning wavelength boundaries. And then we initiate the scan and measure peak power. Once we've done that, then we enter our interesting part of the sequence where we have double for loops inside a while loop. So we first hit our first conditional statement where we check if the peak power that we measured is less than 5 dBm. If it is, we enter the loop. Otherwise, we exit the loop and turn off the laser. So once we enter the loop, we first set our attenuation value to 2 dB, and then we check if the attenuation value is less than or equal to 10 dB. If it is, then we go into our first for loop where we go and initiate the scan and measure 3 different measurements. In this case, we're measuring peak power, wavelength, and frequency for each attenuation value. And once we've done that for 2 dB, then we go ahead and increase the attenuation by 2 dB until we reach the maximum attenuation of 10 dB. And we do similar thing where we measure peak power, wavelength, and frequency for each attenuation value until we've exited the loop. And once we exit, we turn off the laser and close the attenuator shutter. And that's the end of the sequence.
And here are the results. If we go to our output tab, we can see, just as explained, from attenuation 2 all the way to 10, the power, the waveform, and the frequency were all calculated to our liking. Thank you very much for listening.
Okay, so
hello, my name is Alex. I wanted
with this demonstration here, right, basically we're gonna make a live demonstration in the breakout room. So please join us there, and we can, if you have any question on the equipment or the process or the logic or the software, please join us to ask there. Now, for us, OptiWave at this moment, because this is a new product, we are looking into different companies or any companies interested in collaboration with us to integrate their instruments with the OptiInstrument tool or to use the software in their instruments to allow the remote control of the instruments. We are open to do that. And please contact us either at my address here, which is email address ahmadatia@optiwave.com, or you can have a question to support@optiwave.com. Thank you very much for listening, and hopefully we'll see you in the breakout room. Thank you. Bye-bye.